Hi, I'm Charlotte Louise from Fungi.com, and today I'm going to be doing a quick video about the physics definition of work. So previously in your physics classes, you've probably been looking at forces and Newton's second law, and so work really just continues looking at forces, but now we're interested in how long the forces are being applied for, because then we can sort of tell what the force is doing to the object beyond just how much it's accelerating it. So our definition of work, and work is normally represented with a W, and you can tell this apart from the W that you probably used for weight, because weight you normally write with a little vector subscript above it, and work is not a vector, so that's important to know. And you can just represent it with a W. And work is equal to the force multiplied by the distance that it's applied for times the cosine of the angle. And here's where it's going to be important that you know what you're using for your angle. So it's probably going to be easiest to use degrees, and it helps if you sort of remember your unit circle from trigonometry, but you can just to be able to check what you're doing on the calculator, but you can definitely, I mean, if you don't remember it, it's not a huge deal. So this cosine of the angle can sort of be confusing for some people, so basically we're just going to go over what that means. So in most cases, you will have a force being applied along the direction that you're going. So we want to know how much work is done if this force is applied for this distance. So in that case, we have work is equal to the force times the distance times the angle right here. The force is, if we were to draw the distance right where the force is, hopefully you can see that, the angle between those two is 0. So if you remember your unit triangle, cosine of 0 is equal to 1. So in this case, we just have force times distance. And in a lot of cases, you're just going to be dealing with this. So sometimes when I'm being lazy, I don't even write out the cosine of the angle, but just to keep yourself clear, I would definitely try and get in that habit of writing out cosine of the angle. So then the importance of this is when you get a case like this, where you have a force being applied upwards slightly. So if we think about it, not all of the force is working to move the block along this way, because part of it is lifting it up a little bit. So in that case, if we take the distance and just sort of draw it up where the force is coming out of, we can see that the angle that it makes is right here, it's that angle. So here, we want to know how much work that specific force is doing on the object. Then we can do work equals F d cosine theta, and we're probably going to get some sort of fraction here. So depending on what angle that is, maybe we'll have 2/3 times FD or 1/3 times FD. So that one's definitely a case that comes along a lot. This next case is something that you might not see quite as often, but occasionally we'll want to know how far something is going up. So we'll have something being pulled up, and maybe we'll have, and we want to know how far it's going up. And we might, instead of wanting to know how much work this force is doing, so how much work I'm doing in pulling up, we might be interested in how much work gravity is doing. And this is where it becomes important. If I'm asking how much work gravity is doing while something's being lifted up, gravity is doing negative work, because gravity would like to pull it in the opposite way. So in this case, we have pretty much 180 degrees. And if you plug that into your calculator, work equals FD times cosine of 180. Cosine of 180 is just -1. So you'll see that this is just going to give you a negative times the force in the distance that it's gone. So that's really important. And we can also have pretty much any angle bigger than 90 is going to give us a negative for the answer in here when we plug it into cosine. So we can do work in a direction opposite to what it's going. You normally wouldn't have something where this is the only force in that case. Normally you have two different things working. So you might want to know like the work that friction does. And that's going to be going in the opposite direction. So that's where cosine of the angle also comes in and is really important. The final case that we have on here, so case 4 if you want to call it, is where we have a force that's literally being applied 90 degrees from the direction of travel. And normally this is just our normal force because we'll have something sitting on a plane. And this is something that physics professors definitely like to ask just because it's sort of tricky and you have to remember. But they'll ask how much work is the normal force doing? And if you use work equals FD cosine theta and you put in, let's see, that's 90 degrees always. When we're on this flat plane, you'll get that cosine of 90 is going to be equal to 0. So you automatically know there that the work's done. But if none, when we just think about it, all this force is doing is pulling it up. It's not helping it move along this distance at all. So that sort of makes sense conceptually too. But yeah, that's a fun one that they like to put in for conceptual problems. So hopefully this video has been helpful, and yeah.